are, oh, did I do that wrong? I'm going to share my screen. And we need to go through chapter 5. All right. So the good thing about chapter 5 is it's our first organ system, but it's an organ system that really does tie back heavily to chapter 4 because it helps us again review and dig in a little bit more into what are the tissues that we have present in this organ system, where they're located, why they're there, and why they have certain proteins or certain characteristics. All right. So um, the integumentary system is what a dermatologist is a specialist in. So your Dr. Pimple Popper lady, this is her thing. She's basically a dermatologist. She's basically, people go to her for acne, for skincare, for cosmetic issues that come from, again, things happening in the dermis, epidermis, even the hypodermis layer that then starts to produce some type of issue visibly in the skin. All right, now you can watch Dr. Pimple Popper in a new light, going, oh, she's just a skin person, an integumentary physiologist. All right, so the integument is the largest system of the body. It's about 16% of your body weight. All right, so you hear about like people getting flayed and they get their skin peeled off. If you do that, you would lose about 16% of your body weight, and it would be extremely painful because there's a lot of sensory system integration into the into the skin. All right. So again, the cutaneous membrane is another name for our integument, our skin. It is going to be the stratified squamous epithelial tissue with the underlying connective tissue, and the immediate connective tissue directly attached to the basement membrane cells. That is going to be your areolar connective tissue to make room for capillaries and the immune cells and the nerves that want to push in and have their receptors right there. And then as you move a little bit further down, it'll mix between dense, irregular connective tissue and then to make room for big features like the blood vessels, the bigger sensory deep receptors, the sweat glands, the hair follicles. You'll have a mix of some reticular fiber connective tissue in there as well. Okay. And so if we talk about what is the integumentary system, it is a mix of the cutaneous membrane or the epidermis and the dermis, the skin, and all the accessory structures that are there to assist keeping the skin pliant, the skin healthy, and then utilize the skin being a barrier to the outside world to have interactions with it. Okay. Now, this picture has basically terminology that you would be expected to know for the lab exam. So this is the picture that you should be able to name everything on here, and then you should be able to also take this picture and replace it with the model of the skin and be able to identify the features on it. All right. So if we use this as kind of our okay, here's our list of vocabulary terms we need to know, this is a really good slide to glom onto. Okay, so again, for the cutaneous membrane, the epidermis is going to be the epithelial tissue of the cutaneous membrane, and you can see it's shown here as the bluer cells underneath are trying to tell you those are the living epithelial cells. Okay, and is somebody trying to get in? Admit. Okay, and then the whiter or the I lost my thing because I came over here. Where's my slides? Okay, I'm just going to put you guys down. Okay, and then these whiter or tanner sides or cells, they're trying to show you that eventually, because it is multi-layered and the cells move away from these capillary beds, that that they will eventually die. And when they die, some of the proteins that are connecting to the cells next to them, some of those proteins are still there. They're still structurally holding on to the proteins, and that's part of how the the cells can kind of form a little bit of a meshwork. Any of the water that was in the cells, that was the cytoplasm when they were living, that has slowly been released, and that's part of your evaporative cooling system that you have no control over. And if you've ever had a blister, so if anybody went and worked in the yard this weekend and you rubbed so many cells that you formed a fluid filled blister, recognize that what you really did was you exploded a bunch of still living fluid cells, and all of the fluid and the molecules that were inside the cells that are no longer living entities, all of that has accumulated and kind of pushed between the still living cells, forming that fluid blister. Okay. Now, the other thing I want you to recognize in this picture is you see how the lower layers of the epidermis, those blue cells, they do kind of go into and form a living unit into the hair root. They kind of are continuous looking with some of the cells that are in your sebaceous or your oil glands associated with the hair follicle and the root. All right. They're just trying to show you that all of those types of cells that form part of the hair follicle and the hair root and form the sebaceous glands, they are all epithelial cells. They might not all be stratified squamous type cells, but they are all epithelial tissues. And so when they talk later on in the chapter about burn patients, and if you have a burn patient that does have 3-degree burns, 3-degree burns means you've lost almost all of the dermis as well as the epidermis. So the thing is, you would potentially have to bring epithelial tissue and graft it on to make new skin, because you lost all of these epithelial kind of populations that could perhaps help you regrow skin if they were to expand and leave their like hair follicle, hair area, or sebaceous gland area. They could expand out. All right. So that's kind of the reason why the picture and the color of those cells looks very similar. Okay. For the dermis layer, they describe it as a papillary layer. So again, it's kind of the area closer to the epidermis, and that's going to be the area where we expect to find some of, if you look over to the right, some of these receptors from the nervous system that are very close, and they push into those dermal papillae hair hills and valleys. Those are your tactile corpuscles. All right. And for right now, you don't need to know their specific names, because there are a bunch of different tactile corpuscles, but we're not going to learn them. We're just going to learn collectively the receptors of the nervous system that push close to the surface of the skin. They are there to give you light touch. They are known as tactile corpuscles. And then the ones that are located more in the reticular layer, the deeper parts of the dermis of the skin, those are for deep pressure and deep vibration. Those are going to be collectively all known as lamellated corpuscles. All right, so you don't need to learn anything more than that. You don't need to learn any more specific names. We'll get to that at the end of the semester. Okay. And again, the reticular layer is going to be where your sudiferous, sebaceous, your hair follicles, your hair roots, and then some of your bigger blood vessels and nerves are pushing into the system. And so the reticular, remember, gives you protein fibers that create a little bit more of a warehouse type feature where you have a lot more open space to put these big items and fit them into the real estate of the dermis. All right. Okay. So if the cutaneous membrane is made up of the epidermis and the dermis, it is connected because as an organ, the cutaneous membrane needs to still be connected to the underlying body. And that underlying body connection is the hypodermis layer, also known as the subcutaneous layer. Okay, so subcutaneous, the connective tissue below the cutaneous membrane, is also known as the hypodermis. And by a technicality, that is not part of the skin. That is the sticky glue that sits on top of skeletal muscle, between mostly skeletal muscle and the skin. So when, again, somebody has their skin peeled off, the hypodermis is the layer between the muscle and the skin. So it is the layering you should see. It's the layering, if you look at your arm and you see your veins running through, all right, it's exactly where those big veins are actually sitting. Okay, so it makes you realize that the epidermis and the dermis are not some places very thick together. They're kind of, again, just enough of a few layers of cells and protein and water, and then there's that hypodermis layer. All right, hypodermis, subcutaneous. So again, when you think about fat, a large number of your adipocytes live in the hypodermis layer. They are known as your subcutaneous fat stores. And in females, remember, estrogen pushes for your fat to be stored in your cutaneous fat, especially in the butt, the thighs, the hips, the belly. All right. And so that's kind of why women sometimes have that apple or pear shape. Okay. Whereas men, your testosterone is going to typically push your triglycerides and your fatty acids to get stored in adipocytes that are actually in your visceral fat. And your visceral fat, remember, is the membranes and the not the membranes, the connective tissue that is between some of the organs. All right, it's part of the connective tissue that's helping with the uh, serous membranes of the peritoneum, those connective tissue areas of that membrane, to have, again, adipocyte populations. And that's where men typically store their fat. And so, again, if we ever look back, and I always think of like the high school coaches, they always wore like their little skinny shorts, their little knee high socks, and then they had these big beer guts because all of their fat was in their belly fat, in and around their abdominal tract organs. All right. And so that's part of, again, a hormone thing pushing fat into the hypodermis or the subcutaneous layer, or it pushes into the visceral. And again, men tend to have visceral fat accumulation, women have that subcutaneous fat accumulation. All right. And so if you ever get some like RU or heart disease. They used to do this thing where they did a tape measurement of the waist, and the tape measurement of the neck. And again, in men, if the waist measurement was beyond a certain number, that was a high risk factor for heart disease and cardiovascular health issues. And it goes back to, well, why would that waist be such a big measurement? And it's because they have a high push of fat into the visceral tissues. All right. Whereas women, the waist might not necessarily always be a very big number. That's why sometimes with women, they do the waist to hip ratio. And they, again, take those two measurements, because if women are going to have a high fat content, they are going to usually see it in and around the butt and the thighs and the hips. Okay. So now you know why sometimes in your health assessments, or back in the day, because in the Air Force, we used to do tape measurements for assessment of body fat and weight management, why they picked those places to measure women versus men. All right. If anyone ever ends up working in some of these weight loss clinics, because those are, again, things that people can end up working with, you can end up doing these measurements. Again, on men, you'd be doing the waist and the neck, and women, probably the waist and the hips. And along with the special scales that take in the biometric, measurements of sending some sound waves or some electrical waves up through the body as they weigh them, they can try to guess how much fat mass versus how much lean muscle mass they have in the system. And you start to then see, are people losing weight because they're starving themselves 2 or 3 days before the weigh-in and just dumping water weight, or are they beginning to lose weight and see physical changes in how much muscle mass they have versus how much fat mass they have? Okay. All right. The other points on here. So the hair follicle, the hair shaft. So the hair shaft is the exposed hair. This is dead tissue. So remember, everything that's kind of tan in this image here for the epidermis part was dead cells. Well, the same thing applies for the hair. Everything that's kind of that tan and exposed to the surface is probably dead epithelial tissue that's keratin rich. All right. Remember, keratin is what makes it very, very waterproof. So every time you now see a commercial, they talk about having healthy hair. Well, your hair is dead hair cells. They can't be healthy because they're dead. So about 4, 5, maybe 3 years ago, you started hearing, I don't know if it was a Pantene commercial or if it was Holly Klum or somebody, they started talking about how the shampoo is about your hair roots, making the hair roots healthy. And that was actually better messaging because it's in the hair follicle and the hair roots that you still have living cells. And so any chemical nutrients that you're trying to target for healthy living cells would be actually in that region of the skin, not the hair shaft, the exposed part, because that's dead. All right. So just be aware next time, again, you hear about shiny, healthy hair. It's like, well, it's dead cells. It's only going to be a function of when the cells were living in the root, in the follicle. Did they have enough nutrients to be able to make enough protein and enough keratin to maybe anchor and hold on to the cells above and below them to make them, when they do eventually get exposed, I guess, look shiny and well connected. So again, just one of those funny things. Your hair is dead. It's not healthy. It's dead. All right. Your hair follicle and your hair root is living. So when you go to get laser hair removal, that hurts. And the reason why it hurts is because they're shooting the laser to burn and basically destroy the living cells in the follicle at the root. And that hurts because attached into the cells at the follicle and the root is a free nerve ending. So that way, again, because all these cells are connected by proteins in their membrane and the keratin they produce, if you pull the hair on the outside, you make a chain reaction of events that eventually get to the root and cause those living cells to then vibrate and intersect with the nerve endings that are embedded in there, and that's how the nerve feels what's happening based on what's going on with the dead parts of the hair. Well, to burn away the hair so you don't have hair in your armpits or hair in your groin or hair on your face or in other unsavory places, you take a laser that's going to burn those cells, and because the nerve ending is right there next to those cells, it hurts because you kind of sometimes accidentally burn and destroy the nerve ending. All right. And so that's why sometimes they put numbing cream to try to help, again, soften the pain that you inflict when you get hair removal, when you burn away the living cells and the nerve endings that are maybe attached or close by. Okay. All right. So the glands, again, a sebaceous gland, the first one listed here, that is going to be an oil gland. All right. You have to tell me in the lab exam that the gland associated here with the hair follicle, all right, and it's kind of a branched gland. So there are branches that come off of it, and then they are going to produce an oil known as sebum, and the sebum is going to utilize the hair shaft that is being grown and the opening that the shaft makes in the epidermis of the skin, and is actually going to come out of the same opening or the same area. So that is part of the reason why oily hair and oil and places we have a lot of hair can maybe be a little bit more oily, a little bit more lubricated than places like the fingers, the pads of our hands where we don't have hair. And so those sebaceous glands, if they are present, they're fewer in number, and they have to have their own little opening. And again, the oil, because those areas are being used maybe more, gets washed away or removed more easily. And so that's why, again, especially right now where you should be washing your hands a lot, the palms of your hands, the fingers, you might find that they're more cracked. The skin's more prone to like cuts and tears and peeling because you are removing the oil, and the oil's not there to keep the skin kind of pliant, the dead tissue, the dead protein cell husk, to keep them a little bit more pliant and movable. All right. The other thing about the reason you make oil to put on your skin, how many of you refrigerate oil? Hopefully nobody. We don't put oil in the refrigerator because in many cases, the pathogens that we worry about, like viruses and bacteria that are trying to come inside of us and take over and propagate and cause us to be sick, they don't live in an oil-based environment. They live in a water-based environment. That's why you have to refrigerate milk and juice and things that are water-based, okay? But the oil is a little bit of a chemical deterrent, because by being on our skin and helping to lubricate our skin, it helps to keep away many things like fungus, mold, bacteria, and viruses from being able to attach to our skin and start propagating and growing in the water that the skin has shed through insensible perspiration. All right. And so the skin then is lubricated with oil to keep it, again, more moist, more pliant. And it's lubricated with oil to also help keep extraneous single-celled and little critters from trying to take up residence inside of us. All right. Now, sweat glands. Okay. It's listed as sweat glands on here. There are going to be, as you read in the book, lots of different names for sweat glands. One of the names to talk about all sweat glands is known as sudiferous glands. Okay. And some of our sweat glands in parts of our body are going to be eccrine or merocrine sweat glands, and they produce what is mostly a watery lubricant. And to get water to move out of our system, that means we have to take some sodium, some chloride, potassium, some chloride, some iron, calcium, whatever ions we can, and we move them outside of the cell into the tube. And as we move solutes into the tube, water's going to follow. Okay. And then that watery secretion is pushed out of the skin, and you can kind of see these little black holes. All right. Those little holes are probably connected to these, again, one long coiled tube. And so if I had a piece of string, here we go. All right. I don't know if you can, let me see if you can see. So if this is the string, all right, and I kind of take one part, I can't do it, and I take one part of the string and I can't, and I roll it up, all right, and then I make this little string rolled up, embed it in my dermis, all right, I'm not sure if you can see that, okay, and then the part, I have a little bit of the string because it's bedded in the in the reticular part of the dermis. All right, it's still one continuous tube. It's just all coiled up into a little kind of yarn ball, and the rest of it protrudes up and through the epidermis. That is a sudiferous American or eccrine sweat gland. Okay, and most of the sweat it produces is going to be a watery liquid solution that's mostly water and then a little bit of solutes. And again, the solutes are predominantly going to be urea, maybe some ammonia, some sodium, some chloride, maybe some hydrogen, some phosphates. The easy little simple ion molecules that we can create to, again, help us get water on the surface of the skin. And the reason why we do the water on the surface of the skin for most of these glands is it can help us flush away some of our waste products. And now we've gotten too big to do efficient waste removal this way, but some of our waste removal is happening this way. And then the other reason is related to the neuroconnection to temperature regulation. Okay, and so the sweat that comes from many of these sweat glands known as merocrine, eccrine, sudiferous sweat glands, that is tied to temperature regulation, and that is known as our sensible, our on-purpose perspiration. And if you've been outside, my parents, everybody lives in Vegas, and they've had like the worst August of years. It's been like 110 every day. And again, in the desert, you sweat so quickly. You are sensible perspirating so quickly, you don't even realize you're sweating. All right. And then you start to lose, again, our body is supposed to be 70% water. When you get down to like 68, 67, you've lost 3% of your body weight of water, you are considered dehydrated. Right. And you get there very quickly if your sensible perspiration is somewhere around 1 to 2, 3 liters per hour. And it can be that in some of these desert environments. Here in St. Louis, when we get really hot, because it is so humid, and my Thailand girl knows this as well, when it's so humid, you are sweating 1 to 2, maybe liters of sensible perspiration per minute. The problem becomes that there's no place in the atmosphere for that water to evaporate to. So you're losing water, but you're not doing an efficient job of also losing heat. All right. And the not losing heat means you're probably then also, what do you call it? I'm making sure I don't have questions. You're also probably becoming dehydrated because you're losing water and you're not losing heat, so you're becoming overheated. So you have potentially a lot of both problems, dehydration and the heat accumulation in your system. Okay, so again, those are your merocrine, your eccrine sweat glands. And again, those kind of sweat glands are like my little string here showed, the one tube, you know, and then the ball of yarn in it. All right, now in the armpits, in our groin area, and you can read about it, they are known as apocrine sweat glands. Okay, and originally, if you go back and you think about glands, we have merocrine glands, which they just secrete, again, just the solutes in the water. We have apocrine glands, which are supposed to be, they release some of their cell membranes, some of the glucose and the fat, the phospholipids that are part of maybe the membrane, and the organelles get released. And then you have your holocrine glands, which, you know, the whole cell explodes and everything that was part of the cell becomes part of the secretion. All right. So again, when we think about our armpits, we think about our pubic area, we also think about smell. And so originally it was thought, well, those glands have to be a little different because the sweat has to have some type of glucose, some type of fat, some type of amino acid and protein molecules part of it, because then bacteria and small critters are living in those areas and using their type of ATP generating respiration, and their respiration makes gas that stinks and it makes BO. All right. And usually those secretions are, again, those what do you call it? Those sweat glands are usually tied to the hair that grows into that region. And the hair that grows into that region is normally a little darker in color, and it's associated with growth at puberty. So there's a tie in to puberty. And if you go to France, this is why they developed cologne. And cologne's a big deal, and they don't shower regularly. And, you know, that's the old rumor. They don't shower regularly. They just douse themselves in cologne to mask their body odor associated with the sweating in their armpits and their groin region. And the sweat from those regions has supposedly apocrine secretions. And so it gives rise to bacterial and small colonies of things growing there that make an odor. All right. And if you look at antiperspirants, what is an antiperspirant? You know, the stick or the spray. The antiperspirant is some type of chemical in there, and it's usually some type of metal like aluminum, aluminum sulfate or something, that's trying to then attack those apocrine sweat glands and trying to reduce their secretions. And that's supposed to help you sweat less, and by sweating less, stink less. And then the deodorant, and some of them are antiperspirant and deodorant. The deodorant is kind of like a perfume. It's just you're putting on a little bit of a powdery type molecule that is going to absorb that apocrine sweat and mask its smell by then secreting a different smell, but also trying to keep the sweat from accumulating and smelling. All right. So again, the apocrine sweat glands, and are they really apocrine sweat glands? No, and it'll talk about that in your book. But again, go back to what do we know? We weren't really good at cell and microbiology. We just knew the sweat glands in our armpits and our groin are tied to the hair follicles that are producing this darker, different hair at puberty. These glands tend to also be tied more to sweat, not just for the heat purposes, but they also get sweat release when we're scared, when we're aroused. So there is some different mechanisms to push those sweat glands to release sweat. And the sweat there, and it could be just coincidence that there's, you know, colonies of bacteria and colonies of things living in your armpit and your groin, because those are moist, warm, dark areas. But again, they originally named it apocrine sweat glands. Okay, so for our purposes of what I want you to do when you look at a sweat gland, all of the plastic models, if we were in real lab, all of them only show these eccrine or American sweat glands. But there are differences in a population of sweat glands. Some of the sweat glands that are in your armpits, in your groin, we call them Apocrine sweat glands or Apocrine sudiferous glands. And again, it goes back to a little bit more of the historical significance of where they're located, but their duct, all right, is going to be like a sebum gland. All right, a sebaceous gland is going to be tied to the hair follicle, but the hair follicle in the groin and then in the armpit, the axillary regions. Remember, those hair follicles produce that more richly darker hair that then in many societies people laser hair remove or shave because we don't want to lift our arms in the air and see arm hair or see when you're wearing a swimsuit, and especially if you're wearing those very exposed Brazilian or banana thong swimsuits, you don't want to see a lot of hair growth. Okay, fun stuff, I know. All right. Nerve fibers. Again, most of the nerve fibers that are not tied to a laminated or a tactile corpuscle, they might be in there for temperature, for pain, for sensation in free nerve ending ways. So there are a lot of nerves in your integumentary system. Some are going to be tied to specialized receptors, and some, if you come back over here and look at this little far left corner, are just free nerve endings. And again, they could be temperature receptors, they could be pain receptors, they could be itch receptors. And for the most part, we'll go through this again at the end of the semester. If a temperature receptor has a range, if you get outside of that range and you go too hot or too cold, that temperature receptor will turn into a pain receptor. Okay, so most of this material, again, you can read about. Vitamin D synthesis comes from our skin. Again, we don't usually let little babies go out in the sun because we worry about them getting exposed to the sun and the UV radiation. So vitamin D can also be taken with milk, and we get vitamin A that way too. But vitamin D is a big part of getting calcium into our bodies from our gut, and then calcium helps build bones. So we see if people are vitamin D deficient, they might be brittly or weak bones, and that in children is known as rickets. We've mostly cured rickets if people can get access to fortified vitamin A, D whole milk. And that's part of the reason why when you see people who are transitioning from breast milk to milk for their babies, they usually start with whole milk that's vitamin D supplemented. If people are doing formula or breast milk, they might also be told by their pediatrician to supplement when they do give some other bottle drink vitamin D drops. And because vitamin D is a fat soluble vitamin, it normally comes in a kind of an oily looking material, juice thing, because in order for vitamin D to stay in solution, it needs to be in an oily, fat environment. And that's part of the reason why we give it in whole milk, because milk then has fat, and the fat can then help keep the vitamin D in solution. Vitamin A is also a fat-based vitamin, so again, why we keep it in, you get more vitamin A and D in fat instead of orange juice or other juices or things that are more water-based. All right, the other thing I want to talk about, again, that dermal papillary, the ridges that are forming between the dermis and the epidermis, that's important, one, to kind of keep the two layers of epithelial and connective tissue together, but it also creates opportunity for blood vessels to push a little bit closer to the middle regions of some areas of the epidermis. So these cells in the stratum, not just the stratum basal, but the stratum granulosum, the stratum, I'm blanking on it, stratum, not lucidium, but the other one, the stratum granulosum, the stratum where it's holding the tent poles up. Oh, it'll come to me in a second. Maybe some of those cells will stay live a little longer because they are a little bit closer to blood supply, oxygen, amino acid, and they can get those nutrients they need to continue to make keratin, to continue to make ATP, and continue to stay alive. Okay. The other thing that the dermal papillae layer push-ins do is, again, for those tactile corpuscles, for those free nerve endings, they can really push close to the surface of the skin. And then in the areas where the epidermis is a little thinner than normal, that means that we're getting our nerves very, very, very close to the external body parts, and it's more able to then maybe intersect and interact and be sensitive to what is going on with the outside environment, right? Because remember, your brain and spinal cord never, ever, ever interact with the outside environment. They get information from nerves and receptors that are close to the outside environment. And so the dermal papillae gives us that ability to do that. All right. All of your epidermal cells, the stratified squamous cells, the living cells living in the stratum basal layer, they are known as keratinocytes because they are cells that make keratin. And you can probably say the cells in the hair follicle are also keratinocytes because they make a lot of keratin as well. All right, and this is a big difference to why the epidermis of the skin is a keratin stratified squamous epithelium. And then when we get to the vagina, when we get to the mouth, when we get to the nose, those are non-keratinized stratified squamous tissues. Because I want to make keratin, I want to make waterproofing on the skin, so water that you throw at me doesn't necessarily immediately come in, and water that I put on the skin for sensible or insensible perspiration stays out on, so it can hopefully evaporate. But in the vagina, in the mouth, in the nose, I don't want as much waterproofing because I want to make sure that I potentially start secreting and mixing the water in that area with the environment and with the chemicals and the saliva or with the mucus that I'm producing for lubrication. All right, here it is. Stratum spinosum, stratum granulosum, and stratum basal. Those three layers would be where we expect to see the cells are still alive. All right, and as the cells move away from the stratum basal, they are going to start to dehydrate. They are going to start to lose their water because they are going to start to lose the ability to maintain a perfect cellular environment because they're not getting as much oxygen, not making as much ATP, as they are getting further away and fighting for those resources from the cells that are closer to the dermal papillary hills and valleys. All right. And so think of a tent. If the tent poles are the only thing holding up the tent starts to sink in on itself. And as that happens, that's why the cell looks like a starfish. It's kind of like tent poles are poking out, but the entire thing is collapsing in as the intercellular contents start to go away with the cell slowly dying. All right. When the cell then just almost is dead, but is just basically turning out as much keratin and as much protein as it can to then, when it's dead, still be this husk of protein interactions with the cells next to it and keratin layered inside. That is when it's at stratum granulosum. And then it goes through this, in the thick pads, a time period where it becomes a little translucent. That's when it's the stratum lucidium. And then the rest of the time, it's just, again, a husk of a cell with the proteins it has inside and on the membrane connected to the cells next to it, and it's now stratum corneum. Okay? And you can go through that. All right? Again, insensible perspiration is like making a blister. Some of the cells, as they're dying, there's still water inside, and that water is slowly being lost to the extracellular environment between the cells. And that water can't always go back into, when you're in the stratum granulosum and the stratum spongiosum layers, back into the dermis of the body. So that water is lost through evaporative cooling. And again, it's water loss that we cannot control. And so that's part of the reason why sometimes it's not really hot outside and it's not really hot inside, but you might get a chill just because your body still is losing a little bit of water as it grows and replaces skin cells every day. All right. The sensible perspiration is, again, the sweat from your sweat glands, both your merocrine in all over your body and your apocrine. And again, those are typically tied to the nervous system telling them to release sweat that then helps you try to massively cool by, again, using the specific gravity of water that it takes so many kilojoules of energy to convert water from its liquid form to its gas form. All right. Last thing we're going to talk about, because it's almost been an hour, is skin color. Okay, in the basal layer and in the dermal papillary layer, there are going to be these melanocytes. All right, and it's genetically determined how many melanocytes you have. Okay, and the melanocytes are going to produce the protein melanin. All right, and the melanin, as the picture shows, is going to be released into the stratum basal and the stratum sphingosum layers to be uptaken and then integrated into those cells as they're making their keratin proteins and their other proteins that when they die are going to just be the husk of the cell left in the stratum cornea. Okay, there's also the protein keratin being made, and remember, keratin is going to give an orangish yellow coloring. Melanin gives the darker blackish brown coloring, and then your other part of your skin color relates to, think of those of us that are of Caucasian descent. If we get really, really hot and our skin floods with blood, we look flushed. Or think of someone who's blushing. As the blood floods into our capillary bed, all of those red blood cells and all of that hemoglobin with oxygen bound to it is going to make the red appearance show up in our skin. Okay, but for the most part, genetically speaking, and this is why if we look at certain people of certain descents, if you lived and your ancestors were from an environment around the equator where the amount of UV light you were being exposed to was higher, you might have, genetically speaking, more active melanocytes producing more melanin to make your skin color darker to absorb as much UV light. So the underlying skins and the cells in the basal membrane area were less likely to be genetically damaged. All right. And then those from some of the Asian descendants have, and Pacific Islanders have more, again, cells producing the keratin proteins, which make their skin a little bit more of that yellow and orange. And again, that's part of them having the skin color that isn't quite like our African descent, but isn't quite like our Caucasian descendants. All right. And then those of us of Caucasian descent, we have a little bit of melanin, we have a little bit of keratin, but we don't have the same amounts because our ancestors grew up in the areas where there were less UV stress. And so they didn't have again, Darwinism, a survival advantage to their skin color being a certain color. Okay. If you ever get yellow because bilirubin shows up, again, bilirubin means your kidneys and the removal of bilirubin when you break down red blood cells is not working. And every day you get rid of 1% of your blood cells. So every day bilirubin needs to be taken out of the circulation by your liver. And if your liver doesn't do that, bilirubin can start to accumulate. And that yellow color is a sick yellow color known as jaundice. That is a different, and that is a bad thing. And that is not normal skin color, but it can also influence skin color as well. Okay? All right. Questions? I'm going to stop the recording. I'm going to try to stop the recording.